So the last force to be found, FBE. Okay? Exact same free body diagram. Okay? So this little section right here. Alright, so I found BE and BD. So C is 100 Newton. BD is negative 200. Okay? This means that in reality, BD is going to the left. Okay? But this free body diagram, you can just keep your assumed direction. Okay? There's no problem. So BE is the unknown here now. Pick a joint. Pick a joint where BE will appear. Okay? In the equation. Pick any joint. Doesn't really matter. Okay? But pick a joint where it's easier to figure out the distance D between the line of action of this guy, BE, and that joint. Okay. So let's see. Obviously, we're not going to pick joint B, right? Because BE would disappear. Joint E would not work either, right? Because we would just use that, and then BE disappear also. Okay. What about joint C? Some moment about joint C. Okay. This means that CE will disappear. CE passes through joint C. Okay, so alright, don't worry about this. This 100 will have a moment about joint C. Okay, but that's easy to figure out. This BD, sure, it will create a moment, okay, about joint C. That's no problem. BE, of course, will create a moment. But the problem is, what is the distance D between this joint C and BE? Well, geometry. This BE is at 45-degree angle. Okay? So the shortest distance between this joint C and BE is the perpendicular distance. This guy right here. Alright, so knowing this triangle, okay, knowing that this is 1 meter, alright, knowing that this is 45 degrees, you can figure it out quite easily. Okay? So in fact, let's do this. So this, let's call it D. Okay? So draw this triangle. Right? So, just draw just the shape, right, to figure out the geometry. So this is 1 meter. This is a right triangle, 45 degrees. Okay? And this is my D. Okay? So use trigonometry, or you can use a similar triangle, right? So let's say I use trigonometry. So say sine 45 degrees, right? Sine of this 45 degrees, right? Equals D over 1. So D is 1 times sine 45 degrees, right? So that's square root of 2 over 2, so 0.707, right? That's good enough. Meters. Okay. So that's the distance D. Alright, so at some moment about joint C. Okay? That's equal to 0. And once again, I'm just gonna make the clockwise direction positive. So first, this 100, okay, times the distance between these two would be 1 meter. Okay, so that's my first moment. Okay, it's positive. Okay, clockwise. And next, BD. Now BD is negative 200. Okay, so just use the result here. Right, so you can keep this direction. That's fine. It's the assumed direction, the wrong direction. Okay, and so BD about C according to this wrong direction is a positive moment, right? Clockwise movement, so positive. However, BD from previous calculation is 200. Okay. Times the shortest distance, which is this right here, and that's 1. Okay. Next, BE, that's the unknown. Okay, so BE, the unknown force, times D, which is 0.707, right, of this calculation right here. Positive, negative, well, BE is assumed to go up this way, so it creates a counterclockwise moment, so negative. Okay. 0. Okay, next, just crunch number. So FBE equals, move that over, do the math, so it was negative 200 plus 100 divided by 0.707. So this is negative, okay, of 100 divided by 0.707. So that's 141.4, okay, or square root of 2 times 100. Okay. That's a negative number, negative value. Negative, once again, means this assumed direction was incorrect. So the correct direction is actually downward. It points down. Okay? So FBE is 141. 141 Newton. Okay? Pointing down means it's tension. Okay. That's it. That's your sections method.